That's Carly. She's saying hello to all of the distance learners. So, Hugo would also like us all to know he forgot his pencil in the last class. There's pencils over there on by the Chromebook cart. I'm just going to keep recording for my distance learners so that they can get a feel of what it's like to actually be in class.
You know, mechanical is such a weird word.
Yeah, mechanical is a weird word. Do you know what else is a weird word? Squirrel. Squirrel.
I can't say.
At school?
Yeah.
Why are you watching Mr. Popper's Penguins at school? Were you in independent study? Oh. Was you writing a report on penguins?
I just wanted to watch Mr. Popper's Penguins.
Is it a cartoon? No, it's a cartoon.
No.
Are there real penguins are in it?
I don't know.
Let's see.
No.
Let's just see an image.
Are you still recording?
Yeah, I'm still recording. I'm only still recording so that our distance learners can get a little bit of the real experience of being in class. But if you're not enjoying this, you can just fast forward. Because after I look up Mr. Popper's Penguins, then we're going to get on. Oh, it's Jim Carrey.
You've never seen Mr. Popper's Penguins?
I'm pretty sure that I have.
Wait, it's the whole movie?
Apparently.
Isn't this like piracy?
I don't know. It's on YouTube. Wouldn't somebody have deleted it by now?
I don't know, maybe.
Look at them cute penguins!
Watch Mr. Popper's Penguins.
I want Hi, Jane. I take it online now. Yep. And Mr. Hubbard texted me and was very concerned.
Light envy?
And was like,
Really?
why haven't you done any of your work? What's
I
going
hate to
on?
break it to you, Captain, but those are fins.
I was like, listen.
I think you might be more
That was
fish than
first.
fowl.
We're in second quarter now. Come on. I haven't done anything.
Oh, I see how it's gonna be. All right, let's see what you got, Billy.
Okay, maybe we should watch this.
Come on, Jenny.
I know on Friday, I'll just play this
Come on.
on my camera and you guys can watch it through Canvas. That'd be hilarious, but also probably illegal. Okay, so we're like 5 minutes in and these poor kids at home are probably like, Mom, come watch this. This is the quality of my distance learning.
Yep. And this is when you say, if you don't want to finish watching, fast forward to 6 minutes.
Just fast forward.
Then back.
Okay, we've been talking about polynomial functions, and we haven't seen any graphs yet. Usually when we talk about functions, we are talking about graphs, but we're getting there today. What the lead up to that is finding zeros. So we solved equations to find zeros. And then last time we talked about what those zeros look like on a graph of a polynomial function. You remember, yeah? So today, on page 50, we are actually talking about the key features of polynomial graphs. Ready? Yes? Okay. Polynomial functions have two shapes. There's really only two options. Either you have what a lot of people refer to as a roller coaster. So I'll usually refer to this as a roller coaster, and so do most of the other 11th grade teachers. So either you have this roller coaster guy, or you have a W or M looking guy. So like this one, I'm going to flip my page really quick. This one is a weird W. This one would be a weird W. This one is a roller coaster. He looks like a roller coaster. So how do they get these shapes? If you have an odd number of roots or zeros, you get a roller coaster. So if you have an odd number of roots or zeros, so that's like x to the 5th, x to the 3rd, you might see x to the 7th. If the exponent or the number of zeros is an odd number, you get the roller coaster. So this would be like y equals positive x to the 5th, and this one is y equals negative x to the 5th. Do you feel okay about that? Okay, so if these ones are the odd ones, then that means that the w's come from the even ones. So that's going to be x squared, x to the 4th, x to the 6th, so on. X is just a line, so that's why x is not written on either of these. And actually, really, it wouldn't be x squared. Erase that one. I'm pretty sure that an x squared only looks like a parabola. You know what I'm saying? For realsies. Okay. So this one would be like positive x to the 4th, and this one would be negative x to the 4th. I don't think that those are the real graph. They're just showing you that this one is positive and this one is negative. Are you okay with that?
Yeah.
Okay, then the other really big thing that they're going to ask you about in your quiz is the end behavior. So down here at the bottom of these pictures, you have this thing called end behavior. So what they're referring to is what is happening at the end of the graph where the arrows are. And the direction that your arrow is pointing is the end behavior. So for this first one, your end behavior is down, comma, up. That is how you describe it. You just say down, up. So then this guy's the opposite because it's the inverse. So this one would be up because the arrow is pointing up, then down. And then it's exactly the same process for the W's and the M's. So for your W, they're both the same. It's up, up. Because your arrows are pointing up at the ends of your graph. Here, down, down. Not too bad, right? So that is the first basics. So number of zeros or number of roots tells you shape. And by number, I mean odd or even. The ends of the graph tell you the end behavior. For this one, let's skip the x-intercepts. Let's skip that for today because that one gets a little crazy. We're already going to have a bunch of info. Okay, so there's a bunch of things that they're going to want to know on this quiz. So one of the first ones is going to ask, is this function, so I'll just call it f of x because he doesn't have a name, is this function written in factored form or standard form? So that goes back to last time. If I pick up my page, I have them labeled. One of them is written in standard and one of them is written in factored. So is this one factored or standard? Factored. And the biggest giveaway is that there's parentheses. last time we talked about counting up the number of roots. So it would be 1 for this x. So 1, 2, 3, 4, 5. So there's 5 roots. So it's an odd, and that's why it looks like a roller coaster. So far, so good?
Yeah.
Yep. End behavior. What's our end behavior? Down, up. So end behavior is down, up. Maybe we should just shorten it to EB, unless you want to write it all out. Okay, let's go way back. And let's talk about increasing intervals and decreasing intervals. So the way I'm walking you through this problem is what your quiz questions look like. So it would be like a drop-down menu. It would give you the function, and then the first one would be, is this in factored form or standard form? You would select factored. It might ask you the roots. It definitely asks what is the end behavior. You would say down or select down, up. And then it asks you how many increasing intervals are there and how many decreasing intervals are there. So you guys see, if you remember, you guys write them down if you know, because we've talked about this before. So how many increasing, how many decreasing? Do it. Really do it. Did you do it, Hugo? Come on. You can do this. You ready to check in? Okay, so the number of increasing intervals is 2. The number of decreasing intervals is 1. And I have them highlighted in different colors. So remember, it's as you go from left to right. So as I go from left to right, this is going up. Then this is going down. And then back up. So 2 increasing, 1 decreasing. You okay with that? Okay, the next thing they're going to ask you is number of maxima and number of minima. So for this one, it's kind of silly because he's a roller coaster, which means he has 1 maxima and 1 minima. What they're asking about is how many low points do you see and how many high points do you see? So this would be your maxima or a maximum. This would be a minimum. You guys also know this as relative max and relative min. So for most of your quiz questions today, it is going to have you do a drop down and select the correct point. There is one where it says enter in the maxima. And what you would need to type in is these numbers with no spaces and no parentheses. And it says that on the problem. It says enter in the relative max with no parentheses, and you would enter in 1.707 comma 2.139, no spaces. Are you okay with that? Okay. This guy here is your absolute min. Why do they gotta call it so many things, right? And usually you would just say your absolute min is the y value, so 0. So this is your y value. That means that your absolute max, and you will have Desmos to help you with this, your absolute max is 2.139. Because remember, it has to be your y value. I think that might trick some of you guys on your quiz. So absolute max, they want the y value. If they say, what is the relative max, then they probably want the point. But it says that. And if you're confused, just have me come tell you so that you don't have to take your quiz 50 times. Okay. Is this one that we could find the roots of pretty easily?
Yep.
Yeah, because it's factored. So this guy's roots for this, so maybe I'm going to write them down here because there's 5. I'm going to write all the roots right here. I think there's only one problem that asks you for roots, and it's factored, just like this. So hopefully it's not too bad. This first one, 1/50th times x, that's going to have a root of 0. Then this is a special binomial. And the biggest mistake that I saw you guys making on the quiz last time was that by the time you got to the quiz, you forgot that you need to root this number. And lots of you guys were putting in 9i and negative 9i, but really it's 3i and negative 3i, because you have to take the root. Are you okay with that one? Okay. What's the root for this guy? Nope. I can see why you're thinking that though. But notice they're different. On this one, the squared is on the x, but where's the squared on this guy? Outside. So what is our root for this one? 4. So 4 and 4. This guy has a multiplicity of 2. Does that jog your memory from last time?
Yes.
Okay. I'm pretty sure that that's all of the things that they ask you about on the quiz. So now let's flip our page and look for this. Oh, thank the Lord. On this one, it actually gives us what we're looking for, because I don't want to be writing out all that stuff. Okay, so question 1, what is our form? Is it factored form or standard form? Factored, and hopefully the parentheses help you decide that. Next question wants to know the number of roots. So we got to be careful when we count them up. This one here would be 2, 3, 4, 5, 6. Now I will write the actual roots for you and you just verify that it makes sense where I'm getting them from. Your roots are -3, -3, 1, 1, 1, 4. Can you guys see where those are coming from? These fractions don't matter. When you go to solve, those fractions don't matter. Okay, so real zeros. Well, I have all the zeros written here, but we can also come down here and check. You have 1, 2, 3 real zeros. I wonder if we're supposed to put 5 there. Because really there's 5, we just have duplicates. You know what I'm saying? I think we're supposed to be writing 5 there. I'm going to leave it as 3. Non-real zeros, none. None of our zeros were imaginary because these are our zeros. Okay, you guys try all of the rest and then we'll check in because we've talked about all of these things before. So I'm going to give you a second and then I'm going to come walk around just to verify that you tried. Wait, did I count those up right? Yeah, 6. I have 6. You guys just give it a try. No, because it doesn't turn the whole time it goes down. Like here, it goes down and then turns, turns, turns. Oh, not necessarily. So for your minima, the number of minima, you have 2 this time. But the number of maxima you have. Does that make sense? Because you have 2 points that are low on the graph that you can see, and then 1 point on the graph that is high. Does that make more sense? Okay, good job. I can see that most of you got at least to the maxima and minima. So let's check in there. So increasing and decreasing. The number of increasing is 2. It's these, this one here and this one here. So these ones, I'll highlight those in like an orangey color. That's increasing, that's increasing. And I'll draw my arrows on like I did before. Then there's only 2 decreasing intervals. This one and this one. There's not 3. It's only 2 because this is decreasing the whole time. It doesn't turn around right here. It just keeps decreasing. So you only count that as 1. Do you guys remember that? We talked about it before. Did anybody remember? No? Okay.
No.
So 2 decreasing, 2 increasing. And the reason why, remember, this is a weird W. And the W's always have 2 and 2. The roller coasters always have 2 and 1. End behavior, up, up. Okay, number of maxima and minima. These are the number of high points that you can see on the graph and the number of low points you can see on the graph. So there is only one maxima, and that is at -1, 5, 3, 4. Because remember, there's that one that you would have to enter it in, and 3, 2, 2, 5. You would plug in exactly what Desmos shows you if you click on the graph. Now the number of minima is different because this time we can see 2 low points. So I'm circling them in pink. Your number of minima, there are 2 of them. There are 2 low points that you can see and 1 high point. Number of turning points, that's where your graph changes directions. So here we go from down to up, then here, up to down, and then one last one here, down to up. So you have 3 turning points. And then relative max and relative min, this is your highest point, and this is your lowest point. You got no Wi-Fi? That's a horrible day. Oh, great. Oh, boy. So on this one, you would say your relative min is -5, 6, 7, 2. Notice that I'm putting the Y value because this guy is the lowest. Do you know what I'm saying? Thank you, Hugo. We're for sure watching the Penguin movie if the Wi-Fi's out. Pretty sure it's illegal though. SpongeBob on the Run. Okay.
Wouldn't that be the X value?
No, it goes X, Y.
Well, because on page 15, for the relative value, you did an arrow for
Oh, I didn't mean to point to the X. I meant to point to like the whole thing, like the whole coordinate.
Okay, that makes sense.
Because it could ask you for either the point or just the Y value.
Okay.
Relative max and min is also the same as absolute max and min. Why they gotta make it so many different words? Okay, so your highest point is 3, 2, 2, 5. Your absolute max is 3, 2, 2, 5. And once again, I'm pulling the Y value for the max and the min. I don't know. I'm starting to feel that way too, though. Okay, I'll add in one question and you don't have to write it down if you don't want to. What is the graph doing from -infinity to -3? Is it increasing or decreasing? So I'm going to darken that up. What is the graph doing from -infinity to -3? So you decide, is it increasing or decreasing? What'd you decide? Decreasing. So this is, over here is negative infinity, and this right here is -3. So what is the graph doing as we move toward -3? It's going down. Do you see what happened there? Do we really not have any Wi-Fi? Yours is working?
Yep.
What one are you on?
Well, it says that it's connecting, but decimal still works.
No, that's not.
Decimal is the only thing working.
No, because at this point you guys need to graph these using Desmos,
I got it already.
but it's not going to be as awesome as if I just do it for you. Do you know what I'm saying? Because if I just graph it, then it's just like I give you another one of these, and it's important that you guys know how to plug it in and graph it and get the answers. So,
Did we do that last time? So technically we should know by now.
so my distance learners, at this point, you can try the quiz if you want, but if not, wait, and I'll either continue this video or make a separate video to tell you where to go from here. So you might be able to do quiz 4-3 right now if you wanted to try it, but if you need to wait, wait. Okay, what I decided, if you're a distance learner, I printed the numbers 1 and 2 at the bottom for these kids so that they would have it, but you plug it into Desmos, because if you're watching this, then your Wi-Fi is working. So plug number 1 and number 2 into Desmos and try to find the answers, and then we'll come back and check in. So I'm going to pause my video, you pause your video, do them. 1 and 2. Okay. Cool. Okay, number 1, we're checking answers. Roots is 3. Real roots is 3. Non-real is 0, because you can see all 3 of the zeros on the graph. Do you see what I'm saying? Yes? Number of increasing intervals is 2. Decreasing is 1. End behavior is down, up. Maxima is 1. Minima is 1. Are you guys checking your answers? Turning points is 2. Local max is the same as absolute max is, oh, that's on my paper, 0.407. And local min is -10.036. And if you wrote the whole point, that's fine too. Okay, then our second one. Oh, is this standard form or factored form?
Standard.
Standard. It asks you that on like a lot of them. This one's factored. Number of roots, 1, 2, 3, 4. The real zeros, all 4 of them are real. Yeah, because this 0 at 1, there's 2 of them. What? No, so there's a total of 4, but on the graph you only see 3 because 1 has a multiplicity of 2. Number of non-real zeros, none of them are imaginary. Increasing 2, decreasing 2, end behavior down, down. Number of maxima 2, number of minima 1. Number of turning points 3. Local max 5, 0, 1, 9, and that's the same as absolute max and min. Local min -1, 3, 6, 4. How'd you guys do? Did you do okay? So you guys will probably need to finish or do the quiz, not finish the quiz in class next time. And we'll have to do the next lesson too. And then distance learners, you can do your quiz now. Okay, goodbye.